Some monuments stand as a silent challenge to everything we think we know about the past. These ancient structures defy earthquakes, wars, and the slow passage of thousands of years. Yet how they were built remains a complete mystery to the finest engineers of our time. This video will take you on a journey to 20 of these timeless monuments, revealing the secrets of civilizations that accomplished the seemingly impossible with nothing but simple tools and profound ingenuity. By the end, you will see human history and our own potential in a completely new light. How did people move 100-ton stones across impossible distances, or build with a precision that rivals our modern lasers? What do you believe is the greatest legacy a civilization can leave behind across the globe and separated by vast oceans? Cultures with no possible contact independently arrived at the same monumental conclusion. In the fertile river valleys of ancient Egypt, along the rugged highlands of Peru, and on the remote islands of the Pacific, a powerful idea took root. This was the belief that humanity could shape the very earth into a legacy meant to endure for thousands of years. What is truly remarkable is not just that they built, but how they built. Without a common language or shared blueprint, these diverse civilizations developed a deep, almost intuitive grasp of mathematics, astronomy, and the hidden properties of stone. They learned to read the stars to align their temples with celestial events, and understood geometry to create structures that could withstand the relentless tests of time and nature. This shared knowledge speaks to a universal human drive, an ambition that pushed people to achieve the seemingly impossible. They were not merely constructing buildings, they were etching their stories into the planet itself, creating a permanent record of their ingenuity for future generations to discover. This foundational spirit of innovation, this desire to reach for eternity, sets the stage for the individual wonders that continue to mystify us today. So what are the specific puzzles that leave modern experts so perplexed? The true mystery of these monuments is not simply their age, but a collection of specific, tangible challenges that defy straightforward explanation. First, there is the sheer scale of the materials. We are talking about stones weighing dozens, even hundreds of tons, moved across vast and often treacherous landscapes. How were these colossal blocks transported from quarries miles away, over rivers and up mountains, without the wheel or modern machinery? Then there is the impossible precision. Stone was cut and fitted so perfectly that you cannot slide a piece of paper between the blocks, a feat achieved without iron tools or laser guides. This masonry is so exact it has survived catastrophic earthquakes that topple modern buildings. Finally, there is the celestial connection. These structures are often aligned with the sun, moon, and stars with an accuracy that implies a deep, sophisticated understanding of astronomy, tracking cycles that span decades or even centuries. When you combine these factors, the conventional story of human technological progress begins to unravel. It forces us to ask a profound question. What if we have underestimated the ingenuity and knowledge of the ancient world? As we begin our countdown, keep these criteria in mind, for they are the keys that unlock the deepest secrets of our past. Our journey begins with the only surviving wonder of the ancient world, the Great Pyramid of Giza. This is not merely a pile of old stones, it is a mountain of precision built by human hands. Consider its placement on the earth. The pyramid's base is almost a perfect square, with its sides aligned to the 4 cardinal directions with an accuracy that rivals modern engineering. Its alignment to true north is so exact, it is more precise than the Royal Observatory in Greenwich, a building designed for that very purpose centuries later. How was such a feat possible with simple tools like wooden rods and copper chisels? The sheer volume of material is equally staggering. To build this colossal structure, workers quarried, transported, and placed an estimated 2.3 million stone blocks. Each one of these blocks weighed several tons, with the largest granite slabs deep inside the pyramid weighing up to 80 tons. Imagine the logistical challenge, moving these immense stones from quarries miles away across the desert, and then lifting them hundreds of feet into the air with perfect placement. The mysteries only deepen when we look inside. The internal chambers and narrow passageways are engineering marvels in their own right. The so-called air shafts, narrow corridors leading from the main chambers, do not simply provide ventilation. Research suggests they were precisely aimed at specific stars in the night sky, like those in the constellation of Orion, potentially linking the pharaoh's journey to the cosmos. This combination of celestial alignment, impossible scale, and breathtaking precision creates a puzzle that has captivated and confounded experts for generations. It stands as a silent, enduring question carved in limestone, challenging our assumptions about what ancient people were truly capable of achieving. Yet the ambition to build on a cosmic scale was not confined to the deserts of Egypt. Far to the north, on the windswept Salisbury Plain in England, another circle of stones whispers a different kind of enigma. Stonehenge stands as an icon of prehistoric mystery, a ring of massive sarsen stones that arrived from quarries over 20 miles away. Some of these monoliths weigh up to 25 tons, a colossal burden to move across the landscape, but the true logistical nightmare involves the smaller bluestones. Geological analysis reveals these rocks originated in the Preseli Hills of Wales, a staggering journey of over 150 miles. How did a society without the wheel, without metal tools, and without draft animals transport dozens of these multi-ton stones across such a vast and varied terrain, navigating rivers, forests, and hills? The proposed methods are as ingenious as they are varied, from rolling them on a complex system of logs to hauling them on rafts along the coast and up rivers. Each theory presents its own set of practical challenges, leaving modern engineers to wonder which, if any, is correct. Once on site, the builders demonstrated a profound connection to the heavens. The entire monument is a sophisticated astronomical instrument, its central axis perfectly aligned with the rising sun on the summer solstice and its setting light on the winter solstice. This was not a random arrangement, it was a precise celestial calendar crafted in stone, allowing its creators to mark the passing seasons with breathtaking accuracy. This combination of Herculean logistics and celestial wisdom creates a puzzle that has captivated humanity for thousands of years, a testament to a forgotten society that looked to the stars and moved mountains to reflect their place in the cosmos. From the ordered stones of Salisbury Plain, we journey to one of the most isolated places on Earth, where a different kind of mystery stares back from the shoreline. On Easter Island, hundreds of massive stone figures, the Moai, stand with their backs to the vast Pacific Ocean, their solemn gazes fixed inland. These are not small carvings. Each statue is a monumental undertaking, hewn from compressed volcanic ash and averaging 13 feet tall with a staggering weight of 14 tons. The largest of them, a true giant known as El Gigante, was never fully raised but would have towered over 30 feet high. The central enigma here is not just their creation, but their incredible journey. The main quarry at Rano Raraku is the source of almost all the Moai, yet the finished statues were placed on ceremonial platforms called ahu, some located miles away across rugged, hilly terrain. How did a people with limited resources move these multi-ton colossi without breaking them? The challenge was then compounded by the final act, the placement of the pukao. These are the distinctive red stone topknots that rest on the heads of some moai, and they are not small decorative items. Each one is a cylinder of volcanic rock weighing up to 12 tons. The question of how these massive stones were lifted and securely placed atop the statues, sometimes dozens of feet in the air, is a puzzle that has fueled decades of debate. Competing theories offer fascinating possibilities. One prominent idea suggests the islanders used a clever rocking motion, literally walking the statues upright by pulling them from side to side with ropes, a method that would have required immense coordination and skill. Others propose a more straightforward approach, using a system of log rollers and sledges. Yet each theory has its flaws, and none has emerged as the definitive answer that satisfies every expert. This leaves the silent journey of the Moai as one of history's most captivating open questions, a testament to a society that invested everything to create a legacy that would forever watch over their land. High in the cloud-shrouded peaks of the Andes, the stone walls of Machu Picchu cling to the mountainside with an impossible grace. This lost city of the Inca is far more than a collection of ruins. It is a breathtaking dialogue between human ambition and an unforgiving landscape. The sheer location presents the first great puzzle. Building a city of this scale on a narrow ridge between two jagged peaks at an altitude of nearly 8,000 feet was a logistical nightmare. Every single stone used in its construction had to be quarried, shaped, and then hauled up staggering inclines, a feat that would challenge modern machinery. Yet the Incas not only achieved this, they perfected it. Their signature technique is known as ashlar masonry, a method so precise it borders on the magical. Each granite block was painstakingly shaped to fit perfectly with its neighbors, locking together in a complex three-dimensional jigsaw puzzle without any mortar at all. The joints are so tight that you cannot slide a knife blade or even a single piece of paper between the stones. This was not merely for aesthetic appeal, it was a stroke of pure engineering genius. When the frequent Andean earthquakes strike, this construction allows the entire structure to dance, the stones shifting and settling with the tremors before locking seamlessly back into place. A dynamic defense system that static, mortared walls could never hope to achieve. This resilience is echoed across the entire mountainside. To create a stable foundation for their city, the Incas sculpted the land itself with hundreds of agricultural terraces. These were not simple garden plots, they were complex layered structures designed with deep gravel bases for drainage, preventing the entire mountainside from washing away in torrential rains. A sophisticated network of stone channels then captured and redirected fresh water from mountain springs, supplying the entire city and feeding fountains that still flow today. When you stand before these walls, the question is unavoidable. How did a civilization without the wheel, without iron tools, manage to tame such a formidable environment with such flawless precision? The answer remains carved into the stone, a silent testament to a knowledge of engineering and harmony with the earth that we are still striving to fully comprehend. From the Incan mastery of stone, we travel to the heart of an empire that built for the masses. The Roman Colosseum is a monument to public spectacle on an unprecedented scale. Its iconic elliptical shape was not just an aesthetic choice, it was a stroke of civil engineering genius designed to seat 50,000 people, all with a clear view of the arena floor. This was a society that understood crowd dynamics on a level that would impress modern architects. Beneath the sandy floor lay the true engine of the spectacle, a labyrinth of underground tunnels and chambers known as the hypogeum. This subterranean world was a backstage universe where gladiators, animals, and elaborate stage machinery were held, all waiting to be lifted by a complex system of pulleys and elevators to the surface for dramatic reveals. The sheer logistical planning to operate this space during an event is staggering to contemplate, but the true secret to the Colosseum's longevity is hidden in its very walls. The Romans developed a revolutionary concrete formula, a recipe that has been lost to time. Unlike modern concrete, which can crumble after decades, the Roman mixture used a specific volcanic ash that actually strengthens over centuries, reacting with seawater to form incredibly durable crystals. This is why the structure still stands after 2,000 years. While many modern buildings require constant repair, the engineering marvels extended to the open air above. A team of sailors was stationed around the top rim to operate the velarium, a massive retractable awning system that could be unfurled to shield spectators from the sun. Managing a canvas canopy of that size in the wind was a feat of practical physics, combined with a sophisticated drainage system to clear rainwater from the vast seating area. The Colosseum represents a complete and holistic approach to public architecture. It was a machine for entertainment, a testament to a civilization that could conceive of, and then successfully build, the seemingly impossible for its citizens. Another metropolis of staggering ambition lies deep within the highlands of Mexico. Teotihuacán was once the largest city in the pre-Columbian Americas, a thriving urban center whose very name, given by the later Aztecs, means the place where the gods were created. Its main artery, the Avenue of the Dead, stretches for miles, flanked by the colossal forms of the Pyramid of the Moon and the towering Pyramid of the Sun. This pyramid is a mountain of human effort, containing over 1 million cubic yards of adobe brick, rubble, and earth. Every single bit of this material was moved and assembled entirely without metal tools, without the wheel, and without any draft animals to assist with the backbreaking labor. The sheer volume of coordinated human effort required to build this single structure is almost incomprehensible, but the mystery deepens when you look not just at the pyramids, but at the space between them. The entire city is a masterwork of celestial alignment. The Avenue of the Dead does not run in a random direction. Its entire length is oriented with a specific and deliberate precision, aligned not to true north, but to a point on the horizon where the Pleiades star cluster sets. This was not a simple feat of observation. It required generations of astronomical tracking and a profound understanding of cyclical time to embed this cosmic connection so perfectly into their urban plan. Who were the people capable of such a grand vision? This is perhaps the most haunting mystery of all. The city was already a magnificent ruin by the time the Aztecs discovered it, its original name and the identity of its builders lost to history. They left no written records, no royal tombs filled with identifiable rulers, just this silent, breathtaking city. The scale of the planning, the perfect execution of its celestial geometry, and the sheer volume of its construction all point to a highly organized, sophisticated society. Yet we do not know what they called themselves, what language they spoke, or why their magnificent city was eventually abandoned. Teotihuacán stands as a ghost of genius, a puzzle without a key, challenging us to understand a civilization that could move mountains to mirror the heavens, yet left no name behind. Perched atop the sacred rock of the Acropolis, the Parthenon appears as a vision of pure geometric perfection. Yet this flawless image is one of history's most brilliant illusions. The ancient Greek architects knew that to make a building look perfect to the human eye, it could not actually be built with rigid, straight lines. To counter the mind's tendency to distort, they employed a series of subtle, almost imperceptible curves and inclines. Each of the massive columns swells gently in the middle, a feature known as intosses, preventing them from appearing pinched from a distance. The columns do not stand perfectly vertical, They all tilt inward, and the entire platform curves upward ever so slightly at the center. This was not a stylistic choice, it was a profound application of advanced optical science, ensuring the entire structure would look balanced and majestic from every vantage point below. The true genius, however, lies in the marriage of this artistic vision with brute force engineering. The gleaming white marble for this temple was quarried from Mount Pentelicus, located over 10 miles away. Each multi-ton block was carefully extracted, shaped, and then transported across that vast distance. The logistics of hauling these immense loads up the steep Acropolis slope remain a subject of awe and debate. Once on site, the builders achieved a level of precision that defies belief. They cut and fitted the marble blocks without any mortar, using complex metal clamps and dowels to lock them together. The joints are so exact that they have withstood centuries of earthquakes, the entire structure shifting as a single, resilient unit rather than crumbling. This incredible durability stems from a deep, intuitive understanding of material and mathematics. The Parthenon's proportions are governed by the golden ratio, a mathematical principle that creates a sense of natural harmony and balance. How did they achieve such a synthesis of art, science, and engineering without modern computational tools? The Parthenon stands not as a ruin, but as a silent masterclass in human ingenuity, a testament to a civilization that sought not just to build, but to achieve a visual and structural ideal for the ages. Deep within the Cambodian jungle, a stone universe emerges from the earth. Angkor Wat is the largest religious monument ever built, a sprawling complex designed as a perfect microcosm of the Hindu cosmos. Its central towers represent the mythical Mount Meru, the axis of the world, while its vast outer moat symbolizes the cosmic ocean encircling all of creation. This was not merely a temple, it was a breathtakingly ambitious act of world-building in stone. The entire layout is a celestial map, with its gates and corridors aligned to the movements of the sun and stars, turning the very ground into a reflection of the heavens. But the true genius of Angkor Wat is not just above ground, it is hidden in the water that surrounds and sustains it. The civilization here engineered the most sophisticated water management system of the ancient world. A sprawling network of reservoirs, canals, and moats functioned like a giant hydraulic machine. This system did more than just fill the symbolic ocean around the temple. It captured monsoon rains, stored the water through the dry season, and distributed it across the landscape to support a population that may have reached nearly 1 million people. They transformed a challenging environment into a fertile, manageable metropolis through pure engineering foresight. The construction itself presents another layer of mystery. The iconic, gracefully tapering towers were built from massive blocks of sandstone, quarried from a mountain over 25 miles away. These stones were transported along canals and then assembled with an almost impossible precision. They were carefully shaped and stacked without any mortar at all, relying solely on perfect cuts, gravity, and a masterful understanding of balance to remain standing for centuries. How did they achieve such stability, and how did they coordinate the labor of thousands to move such immense quantities of stone? The most haunting question, however, is how a society capable of such grand urban and hydraulic planning could eventually recede, its magnificent city gradually reclaimed by the forest. The temple remains a silent testament to a pinnacle of human achievement, leaving us to wonder what knowledge was lost when the last engineer walked away from its towering gates. The desert wind whispers through a canyon of impossible architecture. In the heart of Jordan, the Rose City of Petra emerges not as a structure built, but as a mountain meticulously unmade. Its most iconic facade, Al-Khosneh or the Treasury, was not assembled block by block but revealed. carvers dangled from ropes and scaffolds, their chisels working from the top of the cliff face downward, a method that turned conventional engineering completely on its head. This top-down approach meant there was no room for error, no way to correct a major miscalculation once the stone was removed. Every column, every statue, every delicate floral motif had to be perfectly planned and executed in reverse, a breathtaking act of faith and precision that still leaves modern structural engineers in awe. How did they visualize the final form so perfectly within the raw stone? And how did they manage the logistics of working at such dizzying heights without a single misstep? But the true genius of the Nabateans lies not just in what they carved, but in what they channeled. In this unforgiving desert landscape, they became masters of a different kind of engineering, one that dealt with the most precious resource of all, water. They designed an intricate network of dams, cisterns, and underground conduits to capture and control the region's violent flash floods. This sophisticated hydraulic system transformed a barren canyon into a thriving, green metropolis, sustaining a population of thousands in the heart of the arid wilderness. The vibrant red sandstone itself tells a story of immense patience and skill, each strike of the hammer not adding material, but revealing a civilization's enduring legacy from within the living rock. A perfect hemisphere of concrete has defied gravity for nearly 2,000 years. The Roman Pantheon's dome is not merely large, it is the world's largest unsupported concrete dome, a record that stands unchallenged by any modern structure. Its secret lies in a masterful manipulation of weight. The architects understood that to support such a vast span, the dome itself had to evolve from its base to its peak. At the heavy, supporting base, the concrete is a dense amalgam packed with travertine and other robust stone, yet as the dome gracefully curves upward, its very substance transforms. The mixture becomes progressively lighter, incorporating porous pumice at the very top near the famous oculus. This was not a random choice, it was a stroke of material science genius, systematically reducing the load on the structure while maintaining its formidable strength. This brilliant design is compounded by an even deeper mystery, the very stuff it is made from. The Romans possessed a concrete recipe that has been lost to the ages. Their unique mixture, which incorporated a specific volcanic ash, possesses a remarkable quality. Unlike modern concrete, which can weaken and crack over decades, the Roman version seems to grow stronger with time, its chemical structure actually improving as it reacts with moisture in the air. This self-healing quality is something our own engineers are still striving to replicate. How did they calculate the precise stresses and perfect the geometry of this flawless hemisphere without the advanced mathematics we rely on today? Pantheon's dome is more than an ancient relic. It is a living, breathing question posed to our modern understanding of engineering, a silent challenge cast in concrete and light. Far from the orderly geometry of the Pantheon, a different kind of mathematical wonder rises from the Yucatan jungle. The step pyramid of El Castillo at Chichen Itza is not merely a temple, it is a stone embodiment of the Mayas' profound connection to the cosmos. This structure is a masterpiece of multi-layered genius, where astronomy, mathematics, and architecture merge into a single, breathtaking form. Its most famous spectacle occurs during the spring and autumn equinoxes. As the sun sets on these two precise days each year, a play of light and shadow unfolds across the pyramid's northwestern staircase. The triangular patterns cast by the stepped corners create the undulating illusion of a giant serpent, its body slithering down from the temple at the summit to meet its stone head at the base. This was not a happy accident, it was a meticulously calculated effect, a demonstration of celestial alignment so precise it could only be the product of generations of astronomical observation. But the calendar carved into this pyramid goes far deeper than this annual spectacle. The entire structure is a colossal, functioning timepiece. Each of its 4 stairways contains 91 steps. When you add these together, you get 364. The single top platform acts as the final step, bringing the total to 365, a perfect representation of the solar year. This integration of a complex calendar into the very fabric of the building reveals a society that measured existence with stunning accuracy. Perhaps the most subtle and mysterious design element, however, is one you can hear. Standing at the base of the grand staircase, a single clap of your hands does not return as a simple echo. Instead, it reverberates off the stepped limestone facade, transforming into a sound that uncannily resembles the chirping cry of the sacred Quetzal bird. This was no acoustic fluke. The specific dimensions and angles of the steps were engineered to create this exact auditory phenomenon, blending the spiritual symbol of the bird with the physical act of human presence. How did the Maya, without oscilloscopes or digital modeling, understand the physics of sound reflection well enough to encode such a specific echo into their architecture? This fusion of visual spectacle, mathematical order, and auditory symbolism creates a puzzle that transcends simple construction. It points to a holistic worldview where science, spirituality, and art were not separate disciplines, but interconnected threads in the fabric of a highly advanced civilization. While other monuments were built upward, one in China was carved outward from the living earth. The Leshan giant Buddha emerges from a riverside cliff, a serene colossus gazing over the confluence of 3 powerful rivers. At 233 feet tall, it is the largest stone Buddha in the world, a figure so immense that over 100 people can stand comfortably on its single foot. Its creation was driven by a profound and practical purpose. In the 8th century, a monk named Haitong initiated the project not just for spiritual reverence, but to tame the treacherous waters below. The rivers here were notoriously violent, their swirling currents claiming the lives of countless sailors and fishermen. Haitong believed that the Buddha's presence would calm the waters, and he dedicated his life to a project so vast he would not live to see its completion, an endeavor that would take 90 years to finish. The true marvel, however, is not merely its scale, but the foresight woven into its very stone. The statue is not a solid, monolithic carving, hidden from casual view within the coiled curls of its hair behind its ears and folded within the stone robes is a sophisticated network of drainage channels. This integrated system was designed with brilliant simplicity, allowing rainwater to flow through concealed gutters and spouts, channeling it away from the statue's core and dispersing it safely down the cliff face. Without this invisible engineering, over 12 centuries of rain and humidity would have cracked and eroded the sandstone long ago. This was environmental engineering in its most spiritual form, a project that sought to protect both travelers on the water and the monument itself. It stands as a testament to a civilization that thought in terms of millennia, harmonizing colossal artistry with a deep, enduring understanding of the natural forces it was built to confront. A silent mountain of stone rises from the Indonesian jungle, not as a fortress or a tomb, but as a 3-dimensional map to enlightenment. The Borobudur Temple is the world's largest Buddhist monument, a colossal structure built in the 9th century from over 2 million individual blocks of volcanic stone. What is truly staggering is that this entire cosmic diagram was assembled without a single drop of mortar to hold it together. Each stone was carefully cut and locked in place by gravity and precision alone, a testament to a masterful understanding of balance and geometry. The temple's design is a profound architectural metaphor. It takes the form of a massive mandala, with 9 stacked platforms leading pilgrims on a deliberate upward journey. The lower levels symbolize the world of desire, the middle tiers represent the world of form, and the upper circular terraces ascend into the formless world of pure spirit. This path is not empty, it is a gallery of stone, lined with over 2,600 intricately carved relief panels that depict the life of the Buddha and the principles of his teachings. To walk this path is to read a sacred text carved into the very earth, a spiritual journey made physical. The logistical challenge of its creation is matched only by the mystery of its abandonment. For reasons we still do not fully understand, this magnificent center of worship was deserted, slowly buried by layers of volcanic ash and jungle growth, where it remained hidden from the world for centuries. This very act of preservation by nature raises haunting questions about the civilization that built it and the circumstances that led them to walk away. For modern engineers, its resilience is a quiet marvel. Located in a region of intense seismic activity, the temple has withstood the tremors of 1,000 years. Its stability lies in its interlocking design, a structure that can shift and settle without collapsing, much like the stone walls of Machu Picchu. How did its creators plan for such endurance, and what knowledge allowed them to encode a spiritual universe into a mountain of stone that could defy both time and the restless earth itself? High above the former capital of the Inca Empire, the stone ramparts of Sacsayhuamán curve across the hilltops like a colossal serpent. These are not simple stacked walls, but a breathtaking mosaic of gigantic limestone boulders, each one a unique, irregular polygon weighing dozens of tons. The sheer scale is humbling, with the largest stones standing over 20 feet tall and estimated to weigh more than 100 tons. How does one even begin to move such a mountain of rock? Yet the true genius of Sacsayhuamán is not in the mass of its stones, but in the mind-bending precision of their assembly. Each massive block was painstakingly shaped to fit perfectly with its neighbors in a complex, zig-zagging pattern that creates 3 distinct tiers of defensive walls. The joints are so exact that the entire structure was built without any mortar at all, relying solely on the perfect interlocking of one stone to the next. This was not a crude fortress, it was a masterclass in seismic engineering. When the powerful Andean earthquakes strike, the entire wall is designed to dance, the stones shifting and settling with the tremors before locking seamlessly back into place. This dynamic resilience has allowed the fortress to stand unshaken for centuries, while modern buildings around it have succumbed to the same forces. The central enigma that baffles engineers today is the how. How were these colossal, irregular boulders quarried from sites miles away, transported across rugged terrain without the wheel or draft animals, and then shaped with such flawless accuracy? The stones do not have straight lines, they feature complex, multi-angled curves that had to be custom fit on site. The prevailing theory suggests that stonemasons used a system of patient pounding with harder stones to slowly shape each block, testing the fit repeatedly until the seam was perfect. But the sheer logistics of maneuvering these multi-ton puzzles into their final positions remains an almost magical feat. It speaks to a society with an unparalleled understanding of geometry, material science, and coordinated labor, a civilization that could convince stone to weave itself into an indestructible tapestry. While some civilizations reached for the heavens, others achieved their greatest marvels by delving deep into the earth. Hidden within the otherworldly landscape of Cappadocia, Turkey, the Derinkuyu underground city is a labyrinth of breathtaking scale, an entire metropolis carved in reverse. This was not a simple cave network, but a meticulously planned subterranean world extending 18 stories down into the soft volcanic rock, a depth equivalent to a modern skyscraper built entirely underground. It was a self-contained refuge capable of sheltering up to 20,000 individuals, complete with everything needed for long-term survival. The city housed families in living quarters, sheltered livestock in dedicated stables, featured places of worship, and even included specialized rooms for pressing wine, suggesting a society prepared to wait out threats for months or even years. The sheer logistical planning to carve such a vast space, ensuring its stability without modern structural calculations, is a puzzle that fascinates geotechnical engineers to this day. How did its architects prevent this multi-level complex from collapsing under the immense weight of the rock above? The answer lies in their intuitive genius. They left thick pillars of untouched stone at regular intervals to act as natural supports, and designed low, arched ceilings to distribute the load, techniques that mirror the principles our engineers use today. But the true test of their skill was managing the basics of life at such depths. A network of over 50 ventilation shafts, some stretching over 100 feet to the surface, provided a constant supply of fresh air to even the lowest levels. Deep, protected wells tapped into the groundwater, ensuring a reliable supply independent from the world above. Security was engineered with equal brilliance. The city was sealed by massive, circular stone doors, each weighing nearly half a ton. These slabs, which could be rolled into place from the inside, blocked the narrow connecting passages, making the city virtually impenetrable to any intruder. This was not a haphazard hideout. It was a masterpiece of defensive and environmental engineering, a testament to a society that looked not to the stars for safety, but deep into the heart of the earth, creating a sanctuary of profound complexity that still feels both impossible and awe-inspiring. A ribbon of stone and earth winds across the landscape for thousands of miles, a feat of ambition that redefines the very idea of a construction project. The Great Wall of China is not a single wall, but a sprawling network of fortifications built and rebuilt over 2,000 years. Its most iconic brick and stone battlements from the Ming Dynasty are what we often picture, but the true secret to its endurance lies in its earliest and humblest form, rammed earth. This technique involved compacting layers of dampened earth, gravel, and clay between wooden frames, then repeating the process again and again. The result was a material with the consistency of soft rock, a man-made stone that has withstood the relentless erosion of centuries, outlasting many structures built with more advanced methods. This was a civilization thinking in terms of millennia, choosing raw durability over immediate grandeur. The sheer logistics of such an undertaking are almost beyond comprehension. Imagine coordinating the labor of millions, from soldiers to peasants, across a frontier of impossible length and some of the most treacherous terrain on Earth. Every single brick, every basket of mortar, every grain of rice to feed the workforce had to be transported over vast distances, up mountain ridges and across arid deserts without a single machine to assist. How did they maintain consistent quality and structural integrity across such a vast and varied project? The answer was a system of accountability as robust as the wall itself. Each battalion was assigned a specific section to build, and they were required to stamp their work with identifying marks. If a section failed or showed poor craftsmanship, the responsible group could be identified and held to account, ensuring that every mile met the same exacting standard. This was perhaps history's first and largest application of quality control on an industrial scale, but a wall is only as strong as its ability to communicate. A threat spotted at one remote watchtower needed to be relayed hundreds of miles along the wall in a matter of hours. The solution was a sophisticated communication network using a combination of smoke signals by day and beacon fires by night, with towers positioned within visual range of each other. A single alert could race across the empire faster than any horse or messenger, a proto-internet of light and fire that turned a static defense into a living, reactive system. The Great Wall stands not just as a barrier, but as a testament to the ultimate challenge of large-scale project management, a lesson in logistics, quality, and communication that continues to command the awe of modern engineers. A fortress that appears to float above the mist Heimji Castle in Japan is a masterwork of defensive genius and elegant beauty. Known as the White Heron for its brilliant white plaster walls and graceful, soaring form, this structure is far more than a castle. It is a complex puzzle box designed to protect its inhabitants at every turn. The journey to the main keep was never meant to be straightforward. The approach is a deliberately confusing maze of winding paths, dead ends, and tightly controlled gates. An attacking army would be forced into these narrow, twisting corridors, where they would be exposed to defenders positioned on the walls above, their progress slowed to a crawl. This was psychological warfare rendered in stone and wood, turning the very ground against any invader. Yet the true marvel of Heimji is how it withstands a far greater and more frequent threat, the earthquakes that shake the Japanese islands. The main keep, a towering wooden structure, is not rigidly anchored to its stone base. Instead, it uses a central pillar and a sophisticated joinery system of interlocking wooden brackets, a technique that allows the entire building to sway and absorb the energy of a tremor. It dances with the earth instead of fighting it, a dynamic defense that has kept it standing for centuries. This resilience is cloaked in that iconic white finish. Plaster coating was not merely for aesthetics, it was a highly functional fireproofing layer, a critical defense in an age of wooden cities and flaming arrows. The specific recipe for this brilliant white plaster was a closely guarded secret, contributing to the castle's legendary status and its pristine survival through periods of conflict. That it has endured wars, hundreds of earthquakes, and the relentless passage of time is a direct result of this holistic design philosophy, where every element, from the confusing ground plan to the flexible wooden skeleton and the protective white skin, worked in perfect harmony. Sometimes the most profound lessons in engineering come not from perfection, but from a spectacular miscalculation. The Leaning Tower of Pisa is the world's most famous architectural mistake, a beautiful flaw that has become an enduring symbol of stability against all odds. Its iconic tilt was not a design feature, but a problem that emerged almost immediately. The builders had laid an inadequate foundation on a fragile base of soft clay, fine sand, and shells. Before they had even finished the third level, the structure began to sink unevenly into the ground, starting a centuries-long battle between human ambition and the relentless pull of the earth. Yet this very flaw is what granted the tower its immortality, forcing generations of engineers to intervene and study the complex soil mechanics at play. For hundreds of years, various attempts were made to correct the lean, some thoughtful and others desperate, but the tower continued its slow, graceful descent. The most critical rescue mission began in the 1990s. A team of international experts embarked on a monumental project to stabilize the structure without destroying its character. The solution was as elegant as it was complex. They carefully extracted small amounts of soil from underneath the raised northern side of the foundation, allowing the tower to gradually settle back in that direction. This painstaking process corrected the lean by nearly 16 inches, pulling it back to a safer angle not seen since the early 19th century. The tower's survival is a fascinating story of unintended consequences, where a foundational error created a unique and ongoing case study in geotechnical engineering. It stands not as a monument to failure, but as a testament to human persistence, a reminder that our dialogue with the natural world is never truly finished. A massive stone lion stares down from a gate that has guarded its secrets for over 3,000 years. The entrance to the ancient citadel of Mycenae is dominated by this iconic structure, a testament to a civilization that mastered the art of moving mountains. The gate itself is a marvel of Bronze Age engineering, its entrance capped by a single limestone lintel block that weighs more than 20 tons. This colossal stone had to be lifted and set perfectly in place to support the immense weight of the wall above, a feat of strength and precision that would challenge modern builders even with their machinery. But the true enigma rests above this massive doorway. A triangular slab of stone, equally immense, is carved with a powerful and mysterious symbol. Two lionesses stand on their hind legs, their powerful frames facing each other and their front paws resting on the altar of a single tapered column. This is not a random decoration, it is a profound statement carved in stone. The meaning of this symbol has been debated for generations. Does it represent the power of the ruling dynasty, a family so strong they could command the king of beasts? Or is it a protective emblem, a spiritual guardian warding off any who would approach with ill intent? The column itself is a puzzle, its distinct shape borrowed from the earlier Minoan civilization, suggesting a complex cultural exchange that we are only beginning to understand. The entire structure, from the perfectly positioned lintel to the intricately carved relief, speaks of a society with immense resources, sophisticated artistry, and a deep understanding of monumental construction. How did they quarry these specific stones, transport them to this mountainous citadel, and then hoist the triangular slab into its precise, gravity-defying position without it shattering under its own weight? The Lion Gate offers no easy answers, only the silent, imposing question of its own existence, a powerful but mysterious greeting from a lost world that continues to challenge our understanding of the past. One man's quiet obsession defies every assumption about how the ancient wonders were built. In the early 20th century, a small, soft-spoken Latvian immigrant named Edward Līdzkalnis began a solitary project in Florida that would become one of the most perplexing engineering puzzles of the modern age. Working almost entirely alone, often under the cover of darkness, he single-handedly quarried, carved, and arranged over 1,000 tons of massive coral rock. The result is the Coral Castle, a complex of monumental sculptures that includes a 9-ton stone gate so perfectly balanced it could be opened with the push of a single finger. He built a rocking chair from solid stone that moves with a gentle nudge and carved enormous tables and thrones, all with only the most basic hand tools. When asked how he managed such impossible feats, Edward would offer only a cryptic explanation. He claimed to have discovered the secrets the ancient Egyptians used to build the pyramids, stating he understood the laws of weight and leverage. The methods he supposedly employed, however, remain completely unknown. Witnesses reported seeing nothing more than tripods made from old telephone poles and a collection of chain hoists and hand winches, equipment utterly insufficient for the tasks he performed. How could one man, standing just 5 feet tall and weighing barely 100 pounds, move blocks of stone heavier than those in the Great Pyramid without modern machinery or any outside help? He guarded his techniques fiercely, ensuring no one ever saw him work. This deliberate secrecy transforms the Coral Castle from a simple curiosity into a profound enigma. It stands as a bridge across time, a modern monument built on the ghost of an ancient secret, challenging us to wonder if a single individual, armed with forgotten knowledge, could truly accomplish what our entire modern industry deems impossible. These common threads weave a tapestry that challenges our most basic assumptions. Across continents and cultures, we see a universal application of advanced astronomy, a masterful understanding of local geology, and a profound relationship with the materials at hand. The builders did not fight their environment, they collaborated with it, using the specific properties of volcanic rock, limestone, or river clay to achieve results that modern materials often cannot match. And then there is the silence, the puzzling absence of detailed records. Where are the engineering plans for the Great Pyramid, the foreman's diary for Sacsayhuamán, the architect's notes for the Pantheon's dome? This lack of a paper trail forces us to listen more closely to the stones themselves and to consider theories that step outside conventional history. One compelling idea suggests that these cultures possessed a form of sophisticated knowledge that we have since forgotten, a deep understanding of natural forces like acoustics, leverage, and vibration. Could specific sound frequencies have been used to soften stone or make massive blocks easier to move, a concept hinted at in various legends? The story of Edward Leedskalnin and his coral castle gives this theory a modern, if enigmatic, anchor. Other researchers point to the possibility of advanced tools, not necessarily complex machines, but simple yet incredibly effective technologies that have been lost to time. Perhaps they used stoneworking techniques or compound leverage systems so efficient that their methods became a specialized secret that died with its masters. This leads to the most radical question of all. Does the existence of these monuments force us to reconsider the very timeline of human progress? The linear narrative, where technology advances in a straight, upward line from primitive to modern, begins to crumble when faced with a 2,000-year-old concrete that is superior to our own, or stonework that withstands earthquakes better than steel-reinforced structures. Perhaps human ingenuity is not a slow climb, but a series of brilliant peaks and valleys, with knowledge being discovered, perfected, and then sometimes tragically lost. These 20 monuments are not just remnants of the past. They are signposts pointing to a different kind of human story, one where intelligence and resourcefulness achieved pinnacles we are only beginning to measure. From the deserts of Egypt to the mountains of Peru, these 20 monuments stand as silent, majestic challenges to our modern assumptions. They are not relics of a simpler time, but profound evidence of a different kind of intelligence, one deeply connected to the stars, the earth, and the hidden properties of stone. The enduring mysteries of their construction are not failures of our understanding, but beautiful invitations to keep exploring, questioning, and learning. Perhaps the greatest lesson they offer is that human ingenuity in any era is capable of the extraordinary when driven by a powerful vision. We see a pattern not of primitive struggle, but of sophisticated collaboration with nature, using geometry to defy earthquakes and astronomy to anchor entire cities to the cosmos. These structures ask us to look beyond our own technological pride and consider a different path to achievement, one built on patience, observation, and a profound respect for the materials of the world. If this journey through ancient engineering marvels has reshaped your view of the past, consider subscribing for more deep dives into history's greatest puzzles. We would love to hear which of these timeless monuments baffles you the most, so share your thoughts in the comments below.